Alright, so let's have a look at question 5 part C. And first of all, let's draw up the information that we've been given. So what we have here is we again have this normal curve with mean of 45 and a standard deviation of 8. So here is my rendition of the normal curve. Now down here somewhere we have 37. And up here somewhere we have a k. And we're told that wherever that k is, it must be in just the right spot so that the area underneath the graph between 37 and that k is just equal to 0.4. And we need to figure out what that k is. Now this is a little bit of a problem here, because when we use that inverse normal function on our calculator, it always assumes that whatever area we've given it, it assumes that one end of that area is either at negative infinity if you use the left tail, or positive infinity if you use the right tail. But here, neither end of the area is out at infinity, so we can't actually use that inverse normal function directly. But let's think about what we would need to know to figure out that k using the inverse normal. What would be really great to know is what the area is from minus infinity out here up to k under the graph. If we knew what that area was there, then we'd be set. We would know what, we'd be able to put that into the inverse normal function and figure out what k is. So I'm just going to put that down over here, because this is what I want. I don't actually have this yet, but this is what I'd really, really like at this point. Let's have 45 there. There's going to be a 37 there, and our k is still in the same spot. So what I'd really, really like is this area. The whole big area from minus infinity up to k underneath this graph. But I don't know it. However, what we can see is that this whole big area out here is it's made up of two bits. It's made up, first of all, of this area out from minus infinity up to 37, and then added onto that is this area under the graph from 37 up to k. So let's just break down this big area up into those two bits. So what I'm saying is that if we draw up another normal curve here, there it is. So we have 45 in the middle, and there's our 37, and here's our k. This whole big area out here is equal to the area under the graph from minus infinity up to 37. So this area here, plus the area under the graph from 37 up to k. So this whole big area here is just equal to this area here, plus that area there. So let's write this down. So instead of just using pictures, let's use maths. So in maths terms, this is going to be the area under the graph from minus infinity up to k. So that, in other words, the probability that x is going to be less than this k. And then that is going to be equal to this area here, which is, in other words, the probability that x is less than or equal to 37. And then added onto that, we need this area here, which is just the probability that 37 is less than or equal to x is less than or equal to k. And this is what I want to figure out. So if I'm going to figure that out, effectively what I need to know is these two areas here. Now luckily, I actually know what this area here is because they told it to us. well, I know that this area here is actually just equal to 0.4, so I can actually write this one down. And then what about this area in here, this one here? Well, I know that one end of this area is out at minus infinity and the other end of the area is up at 37, so we could actually use the calculator to figure that out. So what we're going to do is we'll use that NCD function. So I turn this guy back on, go into dist, norm, and NCD. I have that the lower is going to be at, like, let's say minus 10,000. The upper is going to be at 37. And I have a standard deviation of 8 and a mean of 45. So if we just put those numbers in, calculate it, we actually get that that is 0.159, and add the two together. So in actual fact, oh my goodness, we've done it. So now we know what this whole big area here is. It's equal to 0.559. So now that we know this, now that we know this whole big area here, now we can use the inverse normal function on the calculator. So now that we've got that, we can say that, well, k, that is going to be equal to the inverse normal function. I'm going to use the left tail. Our area is 0.559. Standard deviation is 8, the mean is 45. So what does that give us? Our area is 0.559. So apparently that k is 46.2. So that k there is 46.2 apparently. So there was a bit of working out there, so let's just make sure that the answer is correct. So as a check, let's actually go and calculate this area. Let's calculate this area with k being equal to 46.2, because it should give us 0.4. And if it doesn't, then we must have made a mistake. So let's just check that. So I'm going to check by calculating the probability that 37 is less than or equal to x is less than or equal to 46.2. And I'm going to do that with the NCD function. So we need to go into dist again, norm, and NCD. So our lower is going to be 37, upper is 46.2, our standard deviation is 8, and the mean is 45. And luckily, it just happens to give us 0.4. So that's correct. So I can be pretty confident that this k is correct as well, and that that's going to be the answer.